estimated sample standard deviation of 2.1 miles per gallon. We need a 95% confidence interval here too. Notice the critical difference this time around? We only have the sample standard deviation. Right, so because the population standard deviation is completely unknown to us, our whole logic shifts. Step 1, we absolutely must use the t-distribution. We also need to find our degrees of freedom, which is just the sample size minus 1. So 34 minus 1 gives us 33. Step 2, looking at our t-table for 95% confidence and 33 degrees of freedom, we find our t-value is 2.035. Step 3, we compute the interval. We take the mean of 12.2 plus or minus our t-value of 2.035 multiplied by the sample standard deviation of 2.1 all over the square root of 34. Crunching all those numbers together gives us our final confidence bounds, 11.47 to 12.93 miles per gallon. Pretty straightforward once you get the hang of it. And again, we are going to lock in that perfect score with our trusty conclusion template. We write, I am 95% confident the population mean mileage is between 11.47 and 12.93 mpg. Always, always bring the math back to the real-world context the problem provided. Okay, final stretch, section 5, link to hypothesis testing. There is a really beautiful relationship here known as the duality rule. Essentially, a two-sided hypothesis test and a confidence interval, they will always, always give you the exact same answer. If a hypothesized value falls outside your 95% confidence interval, boom, you reject the null hypothesis at the 5% significance level. But if it falls inside your interval, you fail to reject it. They're two sides of the same coin. So, to put that into perspective, let's go back to our lawyer's gas mileage. If someone made a super bold claim that the true population mean is, say, exactly 11.25 miles per gallon, we just look at our calculated interval, which was 11.47 to 1293. Since 11.25 falls completely outside our bounds, we instantly have the statistical evidence to declare that claim invalid and rejected. Our interval represents the exact, specific set of values we consider plausible. And wow, that brings us to the end of our review session. Remember, guys, these aren't just arbitrary formulas you memorize to pass an exam. They are genuinely powerful tools you can use to critically evaluate data and test claims every single day. Seriously, the next time you see a flashy statistic on the news, take a second and ask yourself about their sample, their margin of error, and what the true interval actually is. Good luck on your exams, you're going to crush it, and keep questioning the data.